Okay, now let's take a look at the next thing we talked about here. And here's, oh yes, the distance from the Earth to the Sun, 92,971,288 miles. Now, that's not a constant, that's an average about right around there. The Earth is actually traveling in what we call an elliptical orbit, not a perfect circle. So it changes every day as to how far away we are from the Sun. But the average is right around there. But if I were to say to you, that's a really important number, you really need to memorize it. Not too many of you are going to be very happy with me. And I'll be honest with you, I probably couldn't remember it either. So we use a simpler number. And this is a number used by the scientific community. It's called an astronomical unit, it's the distance from the Earth to the Sun. And that value is 93 million miles. Now look at this. If we kept this average right here, the 8 is the doubtful digit right there. That is telling us that we get 8 significant figures there. That's nice. That's really, precise. But no one wants to remember that. So we go to the 2 and say, let's make that the doubtful digit and round that off. Look at the number next to it. Is it a 5 or greater? It's greater than 5. And we're going to make that a 93. But we can't say it's 93 miles from the Earth to the Sun. We're going to die. Don't die. Don't burn into a crispy critter. Okay, we're 93 million miles, thank goodness. So those zeros have to be placed in there. But this is the doubtful digit, the 3. Okay. So, when it comes to decimal values, less than 1. Now we're getting to decimal. So, beware of the whole numbers. Make sure that the zeros at the end of a whole number are not counted as significant figures. The last one that is not. Now, if you have a 0 between 2 non-zeros, that's okay. Like if we have, I think I may have put that up there, did I? No, I did not. But let's take an example before I move on to the decimal portion of our program. So let's suppose that the distance from the Earth to the Moon is 206,000 miles. How many significant figures is that? Well, it's obvious that we've rounded off to the nearest 1,000. That's your doubtful digit. That means everything in front of it, including the 0, has to be included as actively involved in the measurement. This is 3 significant figures. The 0 is between 2 non-zeros, and in whole numbers that means it's significant. But if I had put like a 3 here, and then all of these zeros in would be significant. But they're at the end of the number. If I drop it, then we're saying there's only 206 miles between us and the Moon, and we're all going to die again, not from heat, but because we're going to collide and we're going to become soup in the classroom. So we got to keep those zeros there. That makes it nearest 100,000, or nearest 1,000 actually. But it gives us 206,000 miles. Okay, now let's talk about the decimals. And these have a fairly consistent like rule to it. I like with the whole numbers, but from a different approach. So let's take this number right here, 0.0001076 meters. Now, hopefully you're noticing one thing about what I'm doing up here. When I have numbers that are greater than 4 digits, either to the left or to the right of the decimal point, I put commas to the left and I put spaces to the right. I want you to do the same thing. So if you're going to write big, long, hairy numbers, you need to include either commas for whole numbers and spaces for the decimals. Or use something called the scientific method or scientific notation, which is what we're going to talk about later on. But for right now, this right here is the doubtful digit. okay? And that means then that everything in front of it is going to be actively involved in the measurement. But, and there's always that big but, what about these zeros? Well, if we got rid of those zeros, that changes the number completely. And since there's no other non-zeros around it, this has the same rule as the zeros at the end of a whole number. That is that these are placeholders. This zero is actively involved in the measurement because of this one right here makes it allowable to be considered a significant figure because it's between two significant figures, two non-zeros. So this is a total of 4 significant figures. Okay? Now, let's take another scenario involving decimals. And let's take a look at, oh yeah, by throwing a 0 on the end of that thing. Yeah, that is an interesting situation right there. Let's bring that back. And let's keep the same number, only now let's stick a 0 on the end of it. Same number, right? If you punch that into your calculator and hit enter, you'll get that. It does not recognize the fact that the 0 belongs there because it is considered the same thing by most people, but also it is going to be an extra piece of information stored in the calculator that the calculator does not want to do. The calculator is all about being small computers and saving memory space, and so little things like zeros at the end of a number they don't like, so they just get rid of it. And you got to be careful of that too, because when we start doing these exercises and deal with significant figures, the calculator doesn't care about sig figs. See, I used the cool term there. You see, that's that sig figs. That's because I'm a cool science teacher. Anyway, so if it didn't have to be there, why would I put it there? What is the point of putting a 0 on the end of that thing? Well, it has to do with the instrument that you use to measure. Let's suppose that the instrument gave us this value right here. That we looked at, it was right on the 6, and the little digital readout for the instrument gave us an extra 0 to show that that's how far it was rounded off to. So that means then that this is the doubtful digit. The fact that it didn't have to be there means that it has been measured to that place, making it significant. And that means then all these numbers up to and including the 1 are all significant. So now we have 5 sig figs. So if it didn't have to be there and it's there, that means it's significant. If it had to be there, that means it's insignificant. I got a little analogy for you. Let's see if this helps you remember that, because this can be a bit confusing. So try this. It's Valentine's Day, and you need to give your boyfriend/girlfriend a gift. Why are you going to give that boyfriend/girlfriend a gift? Because if you don't, you're in trouble. You don't care enough about me. I'm breaking up with you, jerk. Okay, then I better get the gift, because if not, that's going to happen to me. So I buy the gift, and I give the gift to my significant other, and she goes, "Oh, that's wonderful. Thank you for the gift." Okay. Now, let's pick a random day, just any day, October 18th, okay? It's no special holiday, right? Well, it is to me, but for other people, it's no special holiday. So, you buy a gift for your boyfriend/girlfriend, and you give it to your boyfriend/girlfriend, and they look at you like, what did you do that for? And you go, because I love you. Oh, this is wonderful. Now, which gift do you think is more significant? The one that you had to give, or the one that you didn't have to give? Which zeros are significant? The ones that had to be there, or the one that didn't have to be there? Well, the ones that didn't have to be there are significant. The ones that had to be there are not significant. The gift that you gave on a day that you didn't have to give it is very significant. Trust me, for the gift that you gave on a day that you are pretty much expected to give, that you have to give the gift, that's not as significant. You just simply, supplied a demand. Okay? Does that make any sense? All right, try to remember that in this respect here. It'll actually help you do the problems involved in this. So, keeping that in mind, keeping that in mind, here are your practice problems. Give me the number of significant figures for each of those numbers. Okay? Good luck.